In this video, we're going to review and preview a little bit. So let's go back to our review where we originally said risk is a consequence times a probability. That means somebody's going to have to know something about probabilities. And then we later on talked about how to identify a risk. We said you begin with a hazard, you identify the harm that the hazard can cause, and then you would specify the sequence of events that's necessary for this hazard to cause this harm. So here's a familiar sequence of events. This is the Asian carp model. So there has to be a pathway. The carp have to arrive on the pathway. They survive transit through the pathway. They colonize at the other end. They spread, and then the harm is caused. Okay? So probability is what we've been talking about. We said, what's the probability that a pathway exists? Well, we know that exists. That's there. It's a fact, Jack. What's the likelihood that the ANS are going to survive? Well, we don't know. That's uncertain. It's uncertain because of some natural variability there. Sometimes they arrive, sometimes they don't. Some survive, some don't. Sometimes they colonize, sometimes they don't. So we're going to use probability to express what we believe to be true about this uncertainty. And so I've done that here. And these numbers have been populated throughout the model. And we see that here, and just made up numbers, this is a 9% chance that this hazard will cause this harm. So that's all review. Now the look ahead comes in that we don't know what this number is. We don't know what that number is at all. And so we're going to use probability distributions to express our uncertainty about the probability. So I'm going to go to at risk. I'm going to go to define distributions. It's going to be maddeningly slow. And just to keep this simple, we're going to go with a PERT. And I'm going to say it's somewhere between 0.8. It's no less than a 0.8 chance. It's no more than a 0.95 chance. And it's most likely going to be a 0.9 chance. So this is a picture of my knowledge uncertainty. This variable number, this variable probability, sometimes it happens, sometimes it doesn't, is actually an unknown value, and this is what I believe it to be. This is the shape. So I click OK. And I would do a similar thing, putting in distributions for each of these values here. And I'm just doing that quickly and rather arbitrarily. And let's say equal sign risk triangle. 0.35, 0.5, 0.6. Whoops, 0.6. And let's say I'll go up here and I'm going to use beta general, and I'm going to say we'll leave alpha 1 and alpha 2 set where they are for right now, and I'm going to say this probability, it's no less than 0.7 and it's no more than 0.85. A beta is often used to express probabilities because it's naturally confined to the 0-1 range. And now I have distributions in here. So now you see this number here has changed, and when I turn on the Monte Carlo process, we're saying we don't really, we don't really know what that value is. Could be this, could be that, could be these other things, and that's because the probabilities of these probabilities is actually unknown. So the takeaway should be this, that probability is the language of uncertainty. Where it comes into play is usually in describing this sequence of events that has to occur. Sometimes each event has its own probability. Those probabilities may be point estimates, or they may be distributions that reflect our uncertainty about the true value of the probability. And then we have to know those rules of the probability that we were just studying in the last mod, so we know whether to multiply these things in this fashion or in a more complex fashion. So knowing something about probability is going to be essential to good quantitative risk assessment. Everyone need not be an expert in probability, but somebody has to have at least enough expertise that you don't embarrass yourselves.